is writing it down. Alright, let's talk about something incredibly cool: steel abrasives. Now you might think, it's just tiny bits of steel, what's the big deal? But I'm here to tell you the difference between good abrasive and bad abrasive. This is where testing comes in. Testing isn't just about ticking boxes on a quality control sheet. It's about understanding the very soul of your material. It's the only way to know for sure if your abrasive will do the job right, last long enough to be worth the money, and deliver the exact results you need every single time. It's fundamental. Think about it like this. You don't just grab some random metal sheets and hope for the best. You test them, you bend them, you pull them apart to know their limits. We do the same thing with steel abrasives, but on a miniature scale. We need to know how many times can they hit a surface before they turn to dust? How much energy do they deliver with each impact? You could be wasting tons of money on abrasive that breaks down too fast, or even worse, failing to achieve the surface finish or strength your project demands. That's why we don't guess. We measure, we gather data. We turn what could be a chaotic mess into a controlled, predictable, and reliable scientific process. So, the first rule of Abrasive Club is, you must test your abrasive. It's the foundation of everything that follows. It allows us to compare different products not based on marketing claims, but on hard, verifiable evidence. It helps us predict how much abrasive we'll use up on a big job, which is a huge factor in managing costs. Most importantly, it gives us the confidence that the work we're doing is up to spec. It's the difference between just blasting away and true engineering. So, how do we put these tiny steel warriors to the test? Well, we need a standardized way to see how they hold up under fire. For that, the industry has a beautiful piece of equipment, a gold standard, called the Ervin Test Machine, or ETM. It's a miniature shot blasting machine designed specifically for lab work. It lets us see in a very short amount of time how an abrasive will perform over hundreds or even thousands of cycles out in the real world. It's a time machine for durability. The core idea behind the ETM is beautifully straightforward. You take a small, precisely weighed sample of the abrasive you want to test, usually about 100 grams. You put this sample into the machine. The ETM then uses a spinning wheel, just like a full-size blast machine, to hurl those particles at a hardened steel target at a very specific velocity. The particles hit the target, bounce off, and are collected so they can be thrown again. This cycle of throwing, hitting, and collecting is repeated again and again, simulating the harsh environment inside an industrial cleaning or peening operation. After a set number of cycles, say 100 throws, the machine stops. The sample is carefully removed and analyzed. What we're looking for is breakdown. The weaker particles will have shattered into smaller pieces or turned into dust. This dust and the broken down bits are separated out using a sieve, and the remaining usable abrasive is weighed. By comparing the starting weight to the weight of the good abrasive left after the cycles, we can calculate its durability. We can literally chart its life expectancy. This process gives us the two most important metrics for any abrasive. The first is its durability, or life, which tells us how many impacts it can survive before it's no longer effective. The longer it lasts, the less abrasive you'll have to buy over time. The second is the impact energy it transfers. The machine can measure the force of the impacts, which tells us how effectively the abrasive is doing its job of cleaning or peening the target surface. An abrasive might be super durable, but if it's not hitting hard enough, it's useless. The ETM lets us measure both, giving us the complete performance picture. While the Ervin Test Machine gives us the headline story on durability and impact, there are other crucial tests we need to run to get the full picture. One of the most fundamental of these is sieve analysis. This is a wonderfully simple but vital test. We take a sample of the abrasive and run it through a stack of screens with progressively smaller mesh sizes. This separates the particles by size, telling us the exact distribution. Why does this matter? Because consistency is king. If you need a specific particle size for a delicate peening job, you have to be sure you don't have rogue oversized particles that could cause damage. Next up on our list of forensic tests is hardness testing. We use a special instrument called a micro-hardness tester, which presses a tiny diamond-shaped indenter into a particle with a precise amount of force. By measuring the size of the mark it leaves, we can calculate the material's hardness. This is incredibly important. If the abrasive is too soft, it won't be effective at cleaning or peening a harder surface. If it's too hard and brittle, it might shatter on the first impact, creating a lot of dust and driving your costs through the roof. We can also dive even deeper by examining the abrasive's microstructure. This involves looking at a polished cross-section of a particle under a high-powered microscope. What we see tells us a story about how the abrasive was made. We're looking for a structure called tempered martensite, which is the hallmark of a high-quality, durable steel abrasive. If we see other structures or find microcracks and voids, it's a red flag. These are defects that will cause the particle to fail prematurely, no matter what the other tests say. Finally, we can run a chemical analysis. Using a spectrometer, we can determine the exact chemical makeup of the steel itself. We're checking the levels of carbon, manganese, silicon, and other elements. The chemistry is the recipe, and if the recipe is wrong, the final product will be flawed. Too much or too little of a certain element can drastically affect the abrasive's hardness, toughness, and overall performance. All these tests, sieve analysis, hardness, microstructure, and chemistry, work together with the ETM data to give us a complete 360-degree understanding of the material we are about to use. So, we've put our abrasive through this whole of tests. What's the payoff? In the real world, the benefits are huge. For any company that uses steel abrasives, this data is pure gold. The most immediate benefit is the ability to accurately predict consumption. The durability test from the ETM tells you exactly how long your abrasive will last. This means you can calculate, with incredible accuracy, how much abrasive you'll need for a specific job or for a month of production. This leads directly to significant cost savings. Choosing an abrasive based on the lowest price per bag is a classic rookie mistake. A cheaper abrasive might break down twice as fast, meaning you have to buy twice as much. You also have to account for the downstream costs. A low durability abrasive creates more dust, which means more wear and tear on your blast machine parts and more work for your dust collection system. By using the test data to select a high durability abrasive that delivers the right impact energy, you buy less material, spend less on maintenance, and reduce your disposal costs. It's a win-win-win. Beyond the money, testing is the ultimate form of quality assurance. The rigorous testing protocol ensures that every batch of abrasive you use will perform exactly like the last one. This guarantees that your process is stable and your final products meet the required engineering specifications every single time. Testing removes that uncertainty and replaces it with confidence. Ultimately, embracing a standardized testing methodology like the one centered around the Ervin Test Machine elevates the entire industry. When manufacturers test their products rigorously and users demand that data, everyone benefits. Manufacturers are pushed to innovate and create better, more consistent abrasives. Users get more reliable performance, lower operating costs, and higher quality results. Thanks for tuning in. If you enjoyed this video, make sure to hit that subscribe button. Bye!